This is part B of the Math 1314 section 1.4 video. And we left off on the slide previous to this one, so we were just, as a quick summary, going over some characteristics of a function. So now let's go ahead and go over the four ways that we could represent a function. So that will be verbally. You could represent a function with a sentence that describes how the input variable is related to the output variable. Numerically will be, of course, with either a table or a list, a table or a list of ordered pairs. And remember, we'll have the input will be the first coordinate of the order pair. Most of the time we'll use X, and then the output will be the Y, or we may use another letter. Then we do have graphically, and of course, just like the word says, it will be a graph in the coordinate plane in which the horizontal axis represents the input, and then the vertical axis, it represents the output. And then, of course, we have algebraically, which will be by an equation in two variables, because we're talking about, first of all, a relation has to be between two variables or more, but also a function, which is a relation, so it will be in two variables. Most of the time X and Y, but recall that we have been using other letters, such as T or R. So to determine whether the relation is in fact a function, it has to meet all the characteristics that we have been mentioning, and we have to make sure that the input value is exactly matched to exactly one output value. So we went over that on the part A of the section. And so if the input is matched to two or more, then it's not going to be to two or more output values, then the relation is not a function. So that's the main thing that we have to check for. And of course, there are other characteristics, so you can pause the video and read this again if you need to. Okay, so we have an example here. The input, part A says, well, first of all, we have to determine whether the relation represents Y as a function of X. So in this case, of course, X is going to be the input, and then Y is the output. So the first one is a sentence, and it says the input value of X is the number of representatives from a state, and the output value Y is the number of senators. So we know that the number of senators per state is always equal to 2. So in this case, Y will always be equal to 2. And it does not matter what the value of X will be. The number of representatives, that's what X represents. So even if you have two different states with the same number of representatives, then let's say 13, just to think of a number. Even if you have two states with the same number of U.S. representatives, the fact that they're both related to 2, then it still makes it a function, because the 2 is repeating. And the 13 here, even though it could be repeating from one state to another, it's being related to 2, which is the number of representatives varies by the population, but the number of senators is always equal to 2. And so in that case, it will be a constant function. And those type of functions are those horizontal lines that we already looked at on the previous section. So constant function, yes, this is a function. Remember, that was a question. Determine if it is a function. The next one is not a function because we have 2 being related to 11 and we have 2 also being related to 10. In this case, they're 2 different numbers, 11 and 10, so it's not a function. Now for the next example, part C, we have that 1 is related to 0. We have that -1 is related to 0. 0 for x is related to -1 for y. And then we have 2 more pairs. 2 is related to 3 right here. And then we have -2 is related to 3. So in this case, even though that we have some y's repeating, 0 and 0, and we also have 3 and 3, that is okay. The y values may or may not repeat, and that's fine. So part C is function. And remember, this one is also a function, part A. Okay. Now for the next slide, we're going to talk about how in algebra we use equations or formulas to represent those functions, such as the y equals x squared. And again, y is a function of x. X is the independent, and y depends on x, dependent. Okay, so here we have it again. X is the independent variable. We also call it the input. And we have that y is the dependent variable, and we do call that the output. Okay, so we're going to go over how to find domains, the domain of a function, which by now you should remember it is the set of all values taken on by the independent variable, which we are most of the time going to be using x. And the range is the set of all values taken on by the dependent variable, which we already been talking about calling it y most of the time. Now, not all the time. And then at some point, we're going to make that y, which is the dependent variable, we're going to change that for function notation, and it will be f of whatever the dependent variable is, which in this case, not the dependent, the independent variable, which in this case is x. And that's another reason we refer to this as y as a function of x, or it could be f of x, and that is exactly how we read it. It's not multiplication, it's f of x. So the function depends on x. So moving to the next slide, now we're going to introduce function notation, which is the f of x that I was talking about. So we have the equation here, y equals 1 minus x squared, and it describes y as a function of x. So instead of using y, we're going to use f, but because we want to be more detailed about what is the independent variable, or the input, we are going to include that input inside the function notation. So instead of just using the letter f, we will say f of x. And that is the same as saying y as a function of x. So the same equation that we have here, y, we replace that with f of x, and then the rest of the equation, nothing changes, we just have it like that, and they represent the exact same thing. Just important to notice that we don't have to only use F. We could have used G. That's another letter. And sometimes we may use a capital letter, maybe, like for revenue. We could call it something like that. So F is not the only letter, but that's the most commonly used. So function notation is good to differentiate between functions and also to include the variable that it will be the input. So we have here a piecewise defined function, and we call it piecewise because, as you can see here, it is defined into two separate intervals for the domain. This is a domain, the x values that the function can take, but it is divided into two cases, 1 and 2. So because of that, we call it piecewise function. So we have to, in this case, evaluate the function when x equals -1, 0, and 1. So what we're going to do, and for sure you will have a question like this on your test, so please pay attention, and since you have open book test or open notes, you could always refer to this example. So if we want to find, here's the name of the function, f of x. So for the first number that we have here is f of -1. So what we have to check is if the input fits into the first category or the second category. And as you can see, -1 for x, that's what we're saying, it fits into the first category. X is less than 0, right? Because -1 is less than 0. So for that reason, we use that piece of the function. So it will be x squared. So we're going to substitute -1 squared plus 1. -1 squared is a +1 plus 1, we get a +2. So here, f of -1 is equal to +2, meaning that when x is equal to -1, the y value corresponding to it is +2. Now for the next case, x is equal to 0. So when x is equal to 0, our question is, what is y equal to? So we're going to find f of 0. So 0 belongs to the second category because we have the equal part in that inequality symbol. So for any number, any x value that is greater or equal to 0, we use the second piece of the function. So we're going to use that equation, x minus 1. So instead of x, we substitute that with a 0 and then -1. So this is what I'm substituting. On the first equation, on x -1, we use the first piece. So now we're on the second piece, and we can only eat one piece at a time. Sorry, I was thinking about a cake. We can only use one piece at a time. Think about you eating a cake. You can only eat one piece at a time, because if we were to use both cases, then we will get two different values. And remember, for each x, there can only exist one y. So don't ever substitute on both cases, only one. So 0 minus 1 is -1. So then here what we have is that f of 0 is equal to -1. Or in other words, when x is equal to 0, the y value is going to be equal to 1. Okay, this as a point, as a coordinate, will be 0, comma, -1. And then let's just write the other one just for fun. So we have -1, comma, +2. Those are the points that we get. Now let's try with the other x value given to us. So that will be +1. So when x is equal to +1, what is the y value? So we check our two cases and we see that 1 is greater than 0. So we're going to use the second case. So we're going to use that equation, x minus 1. So f of 1 is going to equal to, based on that equation, 1 minus 1, because we substitute the x with the 1. And that gives us 0. So what that means is that f of 1 is equal to 0. In other words, when x is equal to 1, the y is equal to 0. And as a coordinate, we will be 1, comma, 0. 1 for x, 0 for y. Okay, now most of the functions that we will be working with this semester will have a domain that could be all real numbers, unless, even though the equation has the domain of all real numbers, if it's an applied problem, maybe the domain could be changed so that it fits the context of the problem. So there are some other functions that will have a domain that will be restricted, so it will not be all real numbers. So there are some things that we have to learn, and first we have an example here of a rational function, and we will be covering this type of functions in section 2.6. So we call it a rational function because it's the ratio of two polynomials. So one is a polynomial of degree 0, and then x squared minus 4 is a polynomial of degree 2. So that makes it a rational function. Now, just like we covered before that we cannot divide by 0 because we will get an undefined answer, same thing applies to functions. So from the domain, remember I said it was going to be a little more restricted than all real numbers. We have to find those x values that will result in a division by 0. So because we don't want to get an undefined solution. So what we do is we take whatever is in the denominator, x squared minus 4, and we create an inequality saying that we don't want that to equal to 0. So from here we could solve it in two different ways. One will be to factor it as a difference of squares, x plus minus square root of 4 is a 2. And then we could, of course we have that does not equal 0. We could create two inequalities from here, so they are linear. And then solve for x, so it will be x cannot equal to -2, and x cannot equal to +2. So those will be the two exclusions from the domain. Another way to solve this will be same thing. We take the denominator, create the inequality that says that cannot equal to 0. So we could think of taking that -4 across the does not equal sign, and it will go from subtracting to adding because inverse operations. Now at this point you can take the square root on both sides, and the square root of x squared will be x, and the square root of 4, it could be +2 but also -2, meaning that you will have x cannot equal +2 and x cannot equal -2. So then when we write our domain, we will be excluding those two values. Now, if we want to write it as an interval, it will be from -infinity to the smallest number, which is -2, and then union with -2 to the largest value, and then 2. Now notice how I am using parentheses here because I want to exclude those numbers. If I wanted to include them, I will use square bracket, and I don't want to do that. And then we just have to connect it with from 2 to +infinity. And the reason we use the union symbols is because we imagine we have a number line, and I'm just going to draw it here. So you have the number line here, and let's say that 0 is here, you have -2 here, and then you have +2 here. And then here we have -infinity, +infinity. So we want to take everything that is from here, from -infinity to -2, parentheses, but we do not want to include -2. -2 is excluded, and so is +2. So from there, we also want from -2, everything that is between -2 and +2, but without including +2, but everything in between. That's what we're saying with this part of the interval. And then finally, we want everything from +2 all the way to +infinity. And that will be the third interval here. And that was the first one. And with the union symbol, we connect those. Okay, another function that it is extremely picky, well, not as much, I don't know. It's the square root function. And this applies for any type of even roots because we have to exclude negative numbers, x values that will give us negative inside the root. So this is the parent function for the square root function. And for that, we know that if we enter on the calculator the square root of -4, it will probably return some message around error or outside the domain or things like that. So we cannot have negative numbers inside the radical. So we say that for this equation, the domain is going to be everything that is greater or equal to 0. So from the number line, it's 0 is here. We still consider the 0, so we use the square bracket, and then everything that is greater than 0. And we include 0 because f of 0, it is defined. If we substitute the 0 here where the x is, the square root of 0 will give me 0. So that's why we still include 0, as you can see here on the interval, and infinity. With infinity and -infinity, you always use parentheses because those are not set numbers. We're just using them as a symbol to indicate that it's more of a concept and not a set value. So if we want to do, we're going to do some examples here. So let's start with D, since it's the last one we did. So we take what's inside the radical, which is 4 minus 3x, and we want to set an inequality similar to the one we have here, greater than or equal to 0. So I'm going to solve for x, and we're going to have 4 greater than or equal, and I'm going to take this negative 3x and across. So from subtracting is going to be adding, so in other words, positive. And then from here, the 3 is multiplying to the x, so this will be x will be 4 divided by 3. So we go from multiplication to division. So I'm going to read this from, I can read it from left to right, but it's better if you read from the variable. So this says x is less or equal than 4/3. And so with that, if we draw this on the number line, we have 4/3 here. But we're saying less than or equal. So because it is equal, we include 4/3. But it's saying less than. So then we go in this direction. So as an interval, the answer for the domain is going to be, the biggest number is 4/3, so that goes on the right side. And the smallest number is going to be negative infinity, which is here. Now let's go to part B before we forget how to do those. So for rational functions, we take the denominator and create the inequality that cannot equal to 0 because we don't want to divide by 0. So in this case, we're going to have x cannot equal to -5. So to write this as an interval, it will be from negative infinity to -5. Exclude -5 because that's what we're saying. We don't want x to be -5. And then connect it with -5 to positive infinity. With a number line, if we place -5 here, we could see that we want everything except that one. So I'm going to put an open circle that also indicates exclusion, or the parentheses. Open circle because it's not colored in. So we're taking everything from negative infinity to -5. That would be this part. And then we're taking everything from -5 to positive infinity. And that will be this part of the interval. And the union symbol indicates that they are connected. So, and of course, parentheses here indicate that 5 is excluded, just like the does not equal symbol will do. Okay, the first one is like the easiest, so let's get that taken care of. So the domain of this function is going to be the set of all x values that we see. And in this case, because we have specific points, we could refer to this function as a discrete function. So for this discrete function, the domain is going to be the set of the numbers -3, -1, 0, 2, and 4. And then finally, for the volume of a sphere. Now here, the input is the radius of the sphere, and the output is the volume. So the volume of a sphere depends on its radius. Pi is a constant. So if I look at it in terms of a polynomial, it's the polynomial of degree 3 because r to the 3rd power. So the rule for polynomials is that the domain is all real numbers, including negatives and 0. However, for a sphere to exist, it has to have a positive radius. And it could be tiny, tiny, close to 0, but it has to be greater than 0. So we will say that r must be greater than 0. So how do we write this as an interval? it will be, the domain will be from 0, without including 0, to infinity. Let's move on to example 8. And we do have a can of iced tea. So it says you work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. So we have this type of ratio. H to radius is equal to 4, meaning that H to R is equal to 4. As a fraction, it will be H divided by R is equal to 4. And that's the same equation that we have here. So if we want to write, for part 8, it says, write the volume of the can as a function of the radius R. Now, the volume for a cylinder, which is the shape of this can, is the area of the base, that's why I use capital B, times the height. Now, the area of the base of a cylinder is a circle. And so the area of a circle is pi r square. That is what I'm replacing the area of the base with. And then, of course, we still have h for height. So that will be our volume function. However, we want to write this, we don't want to have r and h. We want our function to be the function of volume as a function of r. So we need to eliminate h. So the way we're going to do that is by using the equation that we have here. And if you notice, we have h over r equals 4, and that comes from here. So if I want to solve for r, I can do the following. I can take this r, which is dividing, to the right side, so it will be multiplying, so we'll have 4 times r. Now I want to isolate r, so the 4 is clearly multiplying to the r. So if we take that across the equal sign, it's going to be dividing. So we will have h over 4. So now what I'm going to do is replace the letter h with what we have. Hold on a second. Actually, I should have just stopped here. Sorry. I solved for r, and what I want to do is eliminate h by replacing it with this expression, with 4r. So in other words, we solve for h, or we isolated h. The one that we want to eliminate, that's the one you want to isolate or solve for. So now let's go ahead and replace that h for height. So we have pi r square and then times h. So instead of h, we're going to write 4r. And so the equation that will come from here is going to be, if we multiply r squared times r, is going to give us r to the 3rd power. So just for convenience, I'm going to write the constant term first, 4, and then pi, that's also a constant. And then we're going to have r to the 3rd power because we add the exponent. So that is the answer for part A of the problem. So it will be v equals 4 pi r cubed. Now, we're going to write the volume of the can as a function of the height h. Oh, we already did that. No, wait. Write the volume of the can as a function of the height h. Oh, okay. So let me just, I'm going to go ahead and write the answer for part A here so we're not confused. Okay. And then let's use this space for the other part. So now, since we want to write the function for volume as a function of the height, now we want to eliminate r. So we're gonna, in other words, we're gonna solve for r. So I'm gonna take the equation that I have here, which says h is equal to 4r. So if I want to solve for r, I will take the 4 across, and for multiplying, it will be dividing. So I'm going to have r is equal to h over 4. So now with the volume function that we know as pi r squared times h, we are going to replace r with the expression h over 4 because we're trying to eliminate r. So we're going to substitute r with the expression that we have here. So it's going to be the volume is equal to pi, and then the expression that we're going to substitute is going to be h over 4. We still need to keep the square here, and then times h. So when we square something, we have a fraction, we have to distribute the exponent. So we're going to have h to the second power, but also 4 to the second power, and then still times h. So this is going to equal to, if we multiply straight across, h times h to the third power is going to be, I'm sorry, to the first power is going to be h to the third power. And then pi would still be here on the numerator. And then for the denominator, we're going to have 4 squared times 1 times 1. So it's 16 because it's 4 times 4. So that will be the answer for part B. That is equal to the volume as a function of the height. Since you notice we eliminated r. Okay, the last thing for this section is the difference quotient, and this is one of those formulas that you will revisit when you take calculus, if you do. And what we do to that, the difference with calculus, is that we add this part that describes the limit as h approaches infinity, and then the same formula that we have here. And so you will learn more of that on your next, when you take calculus. So we call it a difference quotient for two reasons. One is a difference right there, and is a quotient because you have two things that, two expressions that will be dividing. And of course, we have to make that exclusion of 0. H cannot be 0 because we cannot divide by 0. So let's get straight to the example, and we have a quadratic function. By the way, you can get the difference quotient of any type of function. We're going to use a quadratic here. So the first thing is to find f of x plus h. And so f of x plus h, just like we used to, for example, if we're asked what is f of 2, you will substitute a 2 in every place where you see an x. And so that will be something like 2 squared minus 4 times 2 plus 7. Now, what we're trying to do here is substitute the expression x plus h. So just like we were to substitute a number, we're going to substitute x plus h. So that would be x plus h squared minus 4 times x plus h, and then plus 7. Now, this part here is the same as if we were saying x plus h times x plus h. And that operation, it is not equal to x squared plus h squared. So please don't do that. What you need to do is actually multiply the two binomials or squaring them. So that product, well, before I forget, I'm going to write the rest here. Minus 4x plus h, and then plus 7. So to perform this multiplication, we're going to multiply x times x. That gives me x squared. Then x times h, so that gives me xh. Then I'm going to multiply h times x, so that will give me hx. And then h times h, so that will be h squared. Now, the two here in the middle are the same. Multiplication is commutative. And then before I combine like terms, I'm going to go ahead and distribute this negative 4 here. So negative 4 times x is negative 4x. And then we have negative 4 times h. It is negative 4h. And let's not forget about plus 7. Okay, so now x squared, I was saying the two here are the same, so we could say that we have two of those. And then we have h squared, and then we have minus 4x, and then we have minus 4h, and then we have plus 7. Okay, so we are done with the first part of the difference quotient. Now we're going to move on to the second part, which is subtract the original function. Which one is the original function? The equation that was given to us here. So that is f of x. So let's write it as a formula. F of x plus h minus f of x over h. That's the formula for the difference quotient. So this part here, we already have it. It's the answer, the long answer that we got. So I'm just going to write that down. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. Then we are going to subtract the original function. So for that, I am going to put a negative sign, and then I'm going to copy the original function. So that is x squared minus 4x plus 7. And then we have everything divided by h. So the next step will be, of course, to distribute the negative sign here. And of course, you can skip that step. That's fine. You could just distribute the signs instead of writing it down inside of parentheses. The reason I do it is just so you could see what needs to be done. Okay, so I'm going to copy what I already had from here. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. And then distributing the negative signs, I'm going to get negative x squared, and then I'm going to get positive 4x, and then I'm going to get negative 7. and then everything is divided by h. Now, I want to check if there are some terms that I could combine. So they have to be like terms, such as x squared positive with negative x squared. They cancel out because they give me 0. They're opposites. Also, I have negative 4x with positive 4x, and then also positive 7 with negative 7. So I have some terms that were canceled. Now I'm going to rewrite what I have. So I have 2xh plus h squared minus 4h, and that's it. Everything divided by h. Now, what we're going to do is take this h and see if we can cancel it out. And the way we're going to cancel it out is by factoring out h from the numerator, because if you notice, all the terms contain at least one h to the first power. So if we factor out the letter h from 2xh, it's like we're dividing. It's like we have 2xh divided by h. So cancel, so we get 2x. Then from h squared, factor out h. So we subtract exponents, so that will be h to the first power, and it's positive. Then we have from negative 4h, we factor out one positive h, and we get negative 4. So that goes here. And the whole purpose of factoring is, of course, I told you, to cancel it. So now that we have h on as a factor on top and bottom, we could cancel them out because they divide equal 1. So then the final answer is going to be 2x plus h minus 4. And that is the answer to the difference quotient. So if you have a problem solving your homework, students tend to struggle with it. Don't hesitate to contact the tutors online, or send me a message through Remind and WebAssign. Okay, last slide is just a summary of function terminology. So I'm just going to leave that for you to read so that we don't make this video longer. Things too that I do want to highlight. We have x is the independent variable, and y is the dependent variable. That would not always be the case, but for this class it will be. Now, all the set of independent variables or inputs, it's called the domain, and all the set of dependent variables, it's called the range or the outputs. So this is the end of the video.